Hi, welcome back. So we are about to close down on the subject of NumPy and the use of this package. Now, I want to show you a function. It's called the index trick. Let's assume, for example, I would have this two-dimensional array. Imagine I would like to select certain item and create from there like a new two-dimensions array. So for example, I want this item and this item to be one row, and I want this item and this item to be another. This is the actual use of something called np.ix underscore function, which is exactly like that. And basically I call the np on this function ix underscore, and it expects two arguments. And the first argument is going to decide on the rows, and the second one is going to decide on the columns. Now, if you run this line of code, you will get back the following result. Here it decide I would like to reach to the first row. Now 0, 1, I'm talking about the 5. So 5 is going to be my first entry on the new array, and 3 is going to be my second row entry, 0, 1, 2, 3, so value of 15. So now I have 5 for the first row and 15 for the second row. Now column wise, what is going to happen expected in this tuple actually here once we print it, and that says I would like you to start from the 0 index and reach out to this particular index on that column. I'm gonna start from the 0, which where I am right now here, and gonna get into the third column. So if I were 0, 1, 2, 3, I'm picking up this value, which is 8. And for the second value, which is 15, I want you to start from there, which is the 0 index as it is, and walk until a third column, so 0, 1, 2, 3. So I want this value to be here. This is called the index trick that you might want to utilize. Now we reach out actually to something called working with mathematical formulas. And I could say that the ease of implementing mathematical formulas that work on arrays is one of the things that make this package in particular, NumPy, so widely used in scientific Python community. Now I'm going to pick up this example about calculating the mean square error. Now if you missed to know what is this, you might want to check our course prediction from the start to the end, where we explain the functionality of calculating mean square error. Now the original mathematical function of calculating that error with this function is 1 over n with the summation from I1 to n, and then you take whatever your model have predicted and subtract it from the original value and then square it. Now imagine I would like to actually implement this using this line to do that. So basically you might assign a value called the error, and then 1 over n, whereby the n is the total number of the samples, just multiply by. Now NumPy, we dealt with something called the sum function. So basically I'm going to get this sum value, it's equal to this. And inside here, we want to calculate this term. So basically I'm going to get the square function in NumPy, and inside that I'm going to get the prediction, which is one array minus another array. Basically, if you wanted to visualize this, it looks like exactly like that. You might write all of this on your own just using Python as we have worked on before. However, if there is actually a functionality that such a package can offer me and save time, I would absolutely utilize it. Now, next thing maybe we want to talk about is how to save and load NumPy objects. Maybe you want to save your array to disk and load them back without having to rerun the code every time. Now, fortunately, we can do that. Something called the load text and the save text function. And maybe I need to make sure that I have the actual path to this folder. And I'm going to create, for example, a new NumPy array.mpy. Now, every time I would like to interact with this array, I have to run this code. But instead of that, I might actually save it into a file, which is going to be down here. And then I can load it again, calling NumPy package.save. And then I decide which file name I would like to use, which is this one. I will be able to see the MP array project has been created. If I want to access to it, actually, one more time, I could say mp.load. So let's run this line and we get the result as exactly expected. Also, you are able to save NumPy array as a plain text file like CSV or TXT, something like that, and get, for example, mp.save save text. Here, basically what I'm going to do, and instead of NumPy, we're going to get into CSV path. Run this line. I expect that I could get the exact same file, which is CSV. np.load the txt of this file path CSV equal to this, and just print the CSV. And here we go, we are getting exactly the same result as expected. So basically we have reached to the last topic, and that is the matplotlib library. And that's exactly what we're going to explore in a while. I'll see you then.